22 over 7. So definitely this is 90 times 22 over 7, which gives you 282.8 square centimeters. 282.8 square centimeters. Let us also consider the question that we have. We are seeing another example that the lampshade shown in the figure has RD of 3 centimeters and 7 centimeter, meaning that the one at the bottom is 7 and the one at the top is 3. So let me sketch it. If we draw it this way, we'll have it like that. So here we are saying for us to be able to work it well, we have to complete it. Then they've also told us that you've been given the height. If its height is 12 centimeters, find its area. It's the height of this that is being given as 12. So in such a case, we have first of all to complete this to its original cone. So we are using a dotted line to form the original cone. Why do we do this? Because there is no way we are going to get our slant height using whatever we have here. We have to use the original cone. So if I look at it, so it means that this height can only work for that part. But now the one that we have added, we do not know the height of it. We do not know the height of the one that we have added, but we know the height of the part of the frustum. Part of the height of the frustum, but we do not have that. We do not have any slant height also. So this one is important for us to understand that for us to work using this. And as I said, this is a lampshade, so the formula for it is pi RL minus pi RL, because it's hollow at the top and hollow at the bottom unless stated otherwise. So if I drew the rectangle triangle from the big one, for the big one, I would have my big radius is 7. Then I will also have this one. So the one that we have added, I've said we do not know its height. So the height is not known, it is x. Okay? Then for the one that we have, the height of the bigger cone is from here to here. So it means that if from here to here is 12 and here to here is x. So the total length is 12 plus x. And the radius of this is 3. So if we look at them, the shape is the same. They have similar shapes. So we use the method of similarity to compare them. For similarity, it means that if we compare the big height, to the small height, should be equals to the big radius over the small radius. Therefore, my big height is 12 plus x. So this side divided by this should be equals to this side divided by this. So what do we do? Cross multiply both sides. Cross multiply. When you cross multiply, we have 3 multiplied by 12 plus x, and this we have 7 times x. When we open the bracket, we get 36 plus 3x, because 3 times 12 is 36 and 3 times x is 3x, is equals to 7x. So 36 is equals to 7x minus 3x. So 36 is equals to 4x. Divide by 4, divide by 4, we get x is equals to 9. x is equals to 9. Therefore, the small height is 9. The big height is 12 plus 9, which is 21. Okay? But have we found our answer? No, because this is h and this is h, and we want L. Then again, after we complete that, we use Pythagoras theorem that if this side is 21 and this side is 7, how do we get this? So our hypotenuse will be given as the square root of 21 squared plus 7 squared. That slant height is L. Then for the small one, it will be given as 3 and 9. Therefore, our small L is square root of 9 squared plus 3 squared. So, if you work it out using your calculator, you find that this one is 81 plus 9, which is the square root of 90, and the square root of 90 is 9.487. And the other one, if you argue 1 squared plus 7 squared is 490. The square root of 490 is 22.14. Then, when we move from there, then what is the curved surface area of the frustum? It's pi RL minus pi RL. So therefore, pi, let me use 22 over 7 times my big radius 7 times my big height, my big slant height 22.14 minus 22 over 7 times my small radius 3 times my big slant, the small slant height 9.487. So you work that out. The first one should give you 487.1. The small one should give you 89.45. So when you subtract the two, you get 397.7 square centimeters. So that is what is happening there. A lampshade, hollow. So if it is hollow, it does not have the base or the top. It's open on both ends, and that is how we work it out. Not given the radius and the depth, you use similarity to get the parts that you do not have. Then after using similarity, you get your L. Then there is the surface area. Then there is the surface area of a sphere. So a sphere is a 3D document. It's a 3D object. So it means that it has, an example of a sphere is a ball. You know, a tennis ball, the football that we play, basketball. Those ones are spheres because they are not circular. You see, they are round. They are round. So even another example could be an orange. This was sphere. Yeah. So that one, for a sphere, it does not have a height. We only have the radius. And that is what we use to calculate the surface area. So the surface area of a sphere is given as 4 pi r squared. 4 pi r squared. So from this, you can only see what we only need is the radius. When now we have our radius, then our answer will be easy to come by. Then from here we can get what we call a hemisphere. A hemisphere is a half of a sphere. So the surface area of a hemisphere is a half of 4 pi r squared. So you end up having 2 pi r squared. In this case, let me call it, this one is for the one that is hollow, like a tennis ball. A tennis ball, once you cut it, whatever you find inside is a hole. The football, if you cut it, it's a hole. But if we have a solid sphere, a solid hemisphere, means that it has a top. An example of a mango, if you cut a mango, it has the curved surface and it also have the top. Therefore, the surface area of a solid hemisphere is given as 3 pi r squared. So 2 pi r for the curved surface plus pi r squared for the top. You add them, you get 3 pi r squared. So for this one, we only need the radius. After getting the radius, you use a calculator. For example, find the surface area of a sphere of radius, let me say 7 centimeters. So, how will we get that? The surface area is 4 pi r squared. So it will be 4 times 22 over 7 times 7 times 7. That way. Then you get your answer. So then find the surface area of a solid hemisphere of radius, let me use 3.5 centimeters. So how do you go about it? Surface area, since a solid, it's 3 pi r squared. So it is 3 times 22 over 7 times 3.5 times 3.5, so on and so forth. So when you use your calculator, you will get the answer here and you also get another answer here. That is how we get this.